9 players are to be divided into 2 teams of 4 and 1 umpire. There you go. How many ways? So we start without restrictions. Fair enough, okay? Now, let's think about this. I always begin with a diagram, okay? Even if you don't end up filling up the diagram with much, it helps you conceptually visualize what's going on, okay? So I have 2 teams of 4. So here's one team, 1, 2, 4. Here's another team, and then here's our umpire, okay? So you got team A, team B, and the loner. I guess that would have been me. So what do you do here? This is not that hard. This is not that hard. You think about it step by step, okay? Let's have a look at team A, shall we? I need to put 4 people on it. How many do I have to choose from? I have 9 to choose from. Remember, there are no restrictions whatsoever. I can pick any of them, right? So this is part A. So to begin with, I've got 9 choose 4, okay? So then I move on to the next team. How many people do I have left to choose from? I've got 5 left to choose from. And how many of them do I need to pick? 4. Okay? Then I have the umpire, right? How many people do I have left to choose from? 1. And I have to choose 1. Okay? Now, that's it. Let's notice a few things before we actually compute this, okay? Number 1, of course you actually didn't need to worry about this one choose 1, did you? Why not? Well, firstly, numerically because it is 1. But why is it numerically 1? Why does it not make an impact? Because once you've picked your 2 teams, there are no more choices, right? That last guy is the umpire no matter what, right? So that's why you don't need to worry about him. I write him down because I'm trying to demonstrate my understanding of the situation. And there is a spot to fill. And there's only one way to fill it, okay? Additionally, do you notice? I didn't have to do it this way, right? Suppose I had drawn my diagram like this. Now you might be thinking at this point, what's the difference? And the answer is not much. It's the same scenario, right? But just replay it with me, okay? How do I work out this probability? Well, you're going to still start with team A. That's 9 choose 4, right? And then you go ahead and you pick an umpire. How many people do I have left to pick from? I have 5. I have 5 people who I can choose to be the umpire. But then at that point, you're in the same scenario you were before. You've got to fill a team of 4, and you've got exactly 4 people to do it with. And there's only one way to do that, right? Okay. So, I mean, these are both 1. They are the unimportant part, right? Once you pick these 2, you're stuck with whoever's left. They've got to go in the remaining spots, okay? And then, of course, you've got these 2, which, of course, we just showed are the same because of the symmetry there, right? You might as well pick 4 people to be on the team or 1 person to not be on the team, okay? Sorry if I'm fixated on this. You can see this is very personal. All right, now, let's just go ahead. Let's work out what the number is. Can you tell me what the number is? Go and crunch it through. 630. Okay. Now here's the problem. We're wrong. Well, I mean, the numbers, right? The calculator was fine, okay? But something is wrong. There are far too many arrangements, okay? Now, it's not just because I know, this is a situation which, like I said, happens at lunch all the time, and you waste the first 15 minutes of lunch trying to work out who's on which team, etc. And I'm like, no way is there this many number combinations, because otherwise it'd be different every time. There are far less than that, okay? And the problem is, what have we not accounted for? What have we missed? Now, to help you try and get it without just telling it to you, maybe it jumps out at you, okay? I want you to think back to my situation with the 4-digit pin, okay? Now, we come back to me and I'm like, I care about permutations and I care about order. So I think about this, right? I crunch it through and then I work out, okay, this is without replacement. So I come up with, 10. I come up with this, okay? And then I hand it to you. And you say, well, some of these are good, but tons of them are actually the same because you only care about which 4 numbers there are. Right? You don't care about which order they're in, okay? So can you see there's an order here that I'm going to hand to you. I'm going to hand you these 630 teams and an umpire arrangements, right? And you're going to look at some of them and say, these are the same. These are the same teams. What have we missed? Has anyone noticed it yet in the last 2 minutes that I've been talking? Aha, right. I will put to you, for example, right? I put the first four, I just did them in order, you know. First four there, you know, your next four here, and then the last guy, okay? There's one of my arrangements. And then another of my arrangements, I start picking completely differently, and I end up with, you know, 5, 6, 7, and 8 over here, 1, 2, 3, and 4 over here, and of course your loner. And you come to me and say, but those are the same teams. You've just put them on opposite sides of the field, but they're the same teams, okay? So I have overcounted by what factor? 2. I should put it, where am I going to put it? I should put it here. Okay, that's the real number of ways, okay? Because there is an order there which I was putting onto it, this A and B business, which isn't there. You don't care about that, you just want the combination. So you divide by 2 factorial, and that gives you 315.